So, summarize all the studies that we've done on all 3 million acres. What we see is when we've got bare soil, and not even a plant will grow here, it's 100% bacterial. Well, you see the same thing with evolution. The first organism that grew on this planet was a photosynthetic, anaerobic bacterium. And those bacteria completely changed the atmosphere of our planet. I just love it when somebody says, bacteria, they're so small. How could they make any difference? Really? They only change the atmosphere so you and I have something to breathe. So, important little critters. So the cyanobacteria, photosynthetic, they fix nitrogen, they solubilize phosphate, they do all these wonderful chemical things, and they make organic matter. So now some of the other true bacteria can come in there. Once we get enough bacteria in our soil, then we're going to get protozoa coming in. And once we have some nutrient cycling going on, now that allows our fungi to have a little bit of food to start growing on, so we start picking up the rest of the food web. Our fungal to bacterial ratio here is 100 times more bacterial than fungal. And so you can express it as that decimal fraction. But of course, all these organisms doing their thing, we're going to get more and more fungi, so pretty soon we have nutrient cycling going on fast enough that at least we can get weeds in the system. And so typically, when we're looking at a bacterial-dominated soil, these bacteria are making alkaline glues. So as they're making these cute little aggregates, those glues from the aerobic bacteria are always going to be alkaline. Alkaline glues being made by all these bacteria, bacterial-dominated soil. So what's the pH of your soil? It's alkaline. It is the biology that controls the pH of your soil. It's the biology that controls the chemistry in your soil. And if we got plants in the system, yeah, we got weeds. Well, the weeds are only putting their roots down a very short distance. So how long is it gonna take to start growing really good nutrient cycling down further and further? So it's a start. We're going in the right direction. But when you're looking at bacteria and fungi, I'm going to use the board over here. If we've got alkaline conditions, so pH is greater than 7, that means the nitrifying bacteria will be making their enzymes to convert the NH4 released by bacteria and fungi being eaten by protozoa, nematodes, microarthropods, earthworms, etc. You can't become a soil food web advisor unless you can say it that fast. Bacteria, fungi, protozoa, nematodes, mycorrhizal fungi, microarthropods, earthworms. Yeah. I've had a little practice, you think? So that's the form of nitrogen that comes out of the protozoa, the nematodes, microarthropods, the earthworms, so forth, when they eat bacteria and fungi. So NH4 is the product. Only when we're in alkaline conditions, so our pH is greater than 7, will the nitrifying bacteria make the enzymes to rip the hydrogens off that nitrogen. Because the nitrifying bacteria need to make energy. That's what the hydrogens are going to do for them. And then those nitrifying bacteria say, there's this annoying oxygen running around here. I don't want to have to deal with that. So I'm going to take those oxygens and stick it on that nitrogen. So then I'm going to convert it to nitrite and then into nitrate. So if we're bacterial dominated, pH is above 7, we've got nitrifying bacteria, all of our nitrate is, bing, converted into nitrate, which is what's required to get your weeds to germinate, get your weed seeds to germinate, to make your weeds really, really happy, and they win in competition. Most of the time our soils are lacking in oxygen. We've got a compaction layer in there because the weeds aren't putting their roots down very far. We're not getting the exudates to grow the bacteria and fungi very deep. And they're putting out mostly bacterial foods. At least we got a little more fungi. 10 times more bacteria than fungi in these kinds of systems. But we're set into the stage to grow the weedy species, things that grow really rapidly, suck nutrients out of the soil, produce billions of seeds, off they go. And now we're going to be growing the next generation of weeds, and you may have 5 or 6 generations of weeds in a single summer. So that's why we don't really like this stage of succession. Everything has gone through that stage of succession. It had to build soil. So Mother Nature is now putting in more cellulose, more lignin, not a lot, but a little, and sooner or later you're going to increase that fungal biomass. And when that happens, we're going to now set the stage to grow early successional grasses like the Bermuda or the Broma species. Not highly productive. And brassicas, broccoli, cauliflower, the kale, the cole, the mustards. Non-mycorrhizal plants for the most part. Fungal bacterial biomass ratio, 0.3. So we still have 2/3 more bacteria than fungi in that soil. But they're making more fungal foods. So sooner or later, depending on a lot of different things, the ecosystem's going to shift because now we've got a lot more fungi, only 1/4 more bacteria than fungi. And so we set the stage for our mid-successional grasses like the ryegrasses, the poas. For most of our vegetables, for most of the solanaceae, carrots, lettuce, those kinds of plants. Right there, because the ratio of fungi to bacteria. Now, keep putting in more fungal foods, a lot more fungal foods here, and pretty soon succession is going to take us to the late successional grass species, the grama grasses, the Kentucky blues, the row crops. So our corn, our barley, our wheat, equal biomass of fungi to bacteria. One of the things that we've discovered is that if we look at the actual values of the bacterium fungal biomass in there, the minimum levels you have to grow a decent crop is 300 micrograms of fungi and 300 micrograms of bacteria. Minimum. If you don't have this level, not going to do very well. You have to have enough to be able to have the nutrient cycling going. If we can get this up to 400 and 400, you must maintain the balance. Typically, you're going to double yields. If you can get this up to maybe 600 to 600, we're going to quadruple yields. Because nutrient cycling is spinning faster and faster. We're maintaining these balances. Protozoa and nematodes, more of the predators, more nutrient cycling. The plant's getting everything it needs. It's going to be tillering more. It's going to have more seeds in the seed head. Number of experiments that we've done. So, what's the highest level you could get to? Would we double yields once again if we got to 800? What if we got to 1,000 and 1,000? We don't know because we haven't gotten there yet. Is there work yet to be done? I would like to challenge you to see if it's actually going to work. If we can get both of these up higher and higher, get the protozoa, the nematodes, we should be able to get higher and higher yields. One thing that we've always seen is that we don't ever decrease yields when we put the biology into the system. When we're going organic, you should not lose yields. And you won't if you've got the biology in. If you pay no attention to your biology, then guess what, folks? You're probably going to have decreased yields because it's the biology that's important here. So we're going to keep going. A lot more fungal foods in here. So we're going to move on to the shrubs, the vines, the bushes. 2 times more fungi, up to 5 times more fungi than bacteria. We're into a fungal-dominated system. And now nutrient cycling is going to shift. It's going to change. Because as fungi become predominant, fungi don't produce alkaline glues. It's what the bacteria do. So as we become fungal dominated, fungi produce organic acids. And the pH on these organic acids is going to be somewhere between 5.5 and 7. So as the fungi become predominant, the pH of our soil is going to drop. And that means our NH4 is going to stay NH4. Because the nitrifying bacteria only make the enzymes to convert NH4 into NO3 under alkaline conditions. The nitrifying bacteria are still perfectly happy. They're living, they're growing. They're just not going to convert NH4 into NO3. So the form of nitrogen in our forest systems, our shrublands, is going to be NH4. We're setting the stage for our perennial plants. These guys require ammonium. This requires nitrate. When we have a balance of fungi and bacteria in the soil, we're going to have an equal amount of nitrate and an equal amount of ammonium. And just about the time we were going through all of this, there was a series of papers that came out from the CEDEX in France and from Utah State University showing that perennial plants require ammonium and annual plants require nitrate. And it came out exactly the time we were doing this. So all of a sudden this made a lot more sense to us. So, where are you in succession? What kind of crop do you want to grow? So, what if you want to grow strawberries? Where in the successional process do strawberries occur? They're understory here in the forest systems. So when you think of a strawberry, what does that fungal to bacterial biomass ratio need to be for your strawberries to grow in an extremely healthy fashion? No diseases, no pests, no weeds. Well, there you go. That's what we need for our strawberries. See, this is not difficult, is it? It's almost simplistic. So, where do pansies come in? Where do they originally come from? From the grocery store? So I love it when kids say that to me. It's like, they come from the grocery store. No. They come from the nursery. No. Where do they originally come from? And so sometimes if you don't know the answer to these questions, where does my Rudbeckia come from? Well, then you go online and you find out where that species of plant originated. What was the part of the planet it came from? And then you can figure out what stage of succession. Pretty simple. What does my plant need? What part of succession do you find it? Potatoes. Where do potatoes come from? South America. And what kind of vegetation, what stage in succession do potatoes come from? High mountain meadows. In the Andes. So that's what we require. Our potatoes need slightly bacterial dominated, but they need a lot of fungi in the system. So you want to grow potatoes without pesticides, without inorganic fertilizers, no fertility problems. You don't want to have to be putting in amendments of any kind. Yep, there you go. Get the ratio of fungi to bacteria right. The higher you can get both, the more productive your potatoes are going to be. For those of you who might want to go to somebody who's doing this kind of work, Rocky Farms in Center, Colorado, has been working with us for about the last 15 years. And most people think of Center, Colorado, down in the San Luis Valley in Colorado as being kind of a semi-arid, arid desert. It's where the Great Dunes National Park is in just outside of Center, Colorado. It's a desert, right? Great big sand dunes. Their farm has turned into an oasis. They don't have to irrigate their potatoes anymore. And that's in Colorado, and places where Water is kind of limiting. So you want to grow potatoes. So what do you want to grow? You can figure that one out.